Hey guys, so this is the key to your study buddy for Module 3 for your test next week. So fill in the blank. If a relationship is blank, then y over x is blank. So y over x should tell you that we're talking about a relationship that is proportional. So if a relationship is proportional, then we know the value of every pair of y and x. If you divide y divided by x, that should be constant. Remember, we talked about constant or variable. So in order for it to be proportional, that y over x for every single pair has to be constant. This value is represented by the variable. Remember, y over x equals k, or k equals y over x is our formula that you'll need to know to find k, which is called the constant of proportionality. So no tricks there. We're talking about a proportional relationship, and it's constant, so that value is called the constant of proportionality. This means it has a constant rate of change. So it's going up the same amount and over the same amount, or down and over. And that is also called the slope. So we learned later in the chapter that that was called slope. Okay, now on the graph of a proportional relationship, we know it's proportional by making sure of two things. We talked about a couple of things. It's a straight line, so it's straight, but it's a line, or has a constant rate of change. That's what it means to be a straight line. It means a constant rate of change. And it goes through that special point called the origin, or 0, 0. So you can either have 0, 0 here or the origin. So that's it for the fill in the blank. Now, if we look at filling out the table, we're talking about slope. So there are many ways to find slope, and I showed you a few different ways, and we used them all. And if you remember, on a graph, we talked about drawing what's called a slope triangle so that we could find remember, R and R, so rise over run. So rise is up and down, run is left and right. Remember that up is positive and down is negative. And then for run, right is positive and left is negative. And when you're trying to find that, you need to make sure you start with the same point. So if I've got 2 points, if I start from this leftmost point, I have to go down. So then when I'm looking at run, I need to start with this point again. So how far over from this point? So you can just start down here, since it's the same left and right anyway, and go to the right. So you can't say, oh, I went to the left, because you need to start at one point. So act like you have to get from one point to the other without lifting your pencil, so you know you have to go down and to the right. So down, that would be a negative, and to the right would be a positive. So this would have a negative slope. And don't forget, we have that chart that shows you that down from left to right is negative slope, up from left to right is positive. Then we have horizontal and vertical, which is undefined. All right, finding change is another way we found slope, and that's when you just find the change in y over the change in x. So change in y over change in x. You got to remember, y is always on top. So you took two values and you said, how do I get from one to the other? Or you subtracted, like if you look back in our examples for slope in 3.2, where we said from day 1 to day 2, day 2 to day 3. So change in y over change in x. And remember, this delta, this Greek letter, means change. And then we have our formula. Remember, this is the second y value in your set of points minus your first y value. That'll tell you how much you've changed. And then divided by the change in x, which is the second x value minus the first x value. You can use any of these methods. I just wouldn't use rise over run if you don't have a graph given to you. Okay, moving on. So this part, you didn't have to fill out anything, but just remember the difference between constant of proportionality k and the rate of change / slope. When you're finding the rate of change or slope, always look at 2 points. You're always looking at 2 points to find rate of change. And you find the change between those two values and the change between the two x values. So the key words here are 2 points that you have to do. And it does not have to be proportional to have a constant rate of change. Remember, we had the case where someone had the bank account where it started with $100 and they increased that by depositing $20 every month. So that had a constant rate of change. It constantly changed, increased by $20, but because it did not go through 0, 0, because they had to put that initial $100 in, it was not a proportional relationship. And we'll talk more about non-proportional relationships next chapter. So when you're finding k, so we are talking about a proportional relationship, you only need 1 point. You just have to do y over k. So, or I'm sorry, y over x. Divide y by x. Only 1 point you need to look at. And that only happens if you're actually finding k, which happens in a proportional relationship. But that k will be the same thing as rate of change and slope. Moving on, we have unit rate. So remember, unit rate, to find that, you first just need to find the rate of change. So you found rate of change before by finding change in y over change in x, or finding the slope. And to make it a unit rate, you need to have the denominator, or the x value, which is always in the denominator. So that's always the x value in the denominator, needs to be equal to 1, because you want to know per 1 of something. For example, you'll have, dollars per hour. Like somebody gets paid, you want to know how many hours it takes them to make $1, because it's going to be a very small number, a fraction of an hour. All right, and the last one is just a comment. If you need help finding rate of change, slope, or constant proportionality, you can put the information in a table to help organize your thoughts. So if you label the x and y, and you put some values in there like 510, 714, 918, things like that, then you can easily find the change. You say, how do you get from 5 to 7? Add 2. How do you get from 10 to 14? Add 4. And then you can take the change in y, 4, over the change in x, 2, and get a rate of change of 2. And you can make sure it's constant by doing the next one. So you're going up by 4 again, up by 2 again. So 4 divided by 2 is still 2. So you would have a constant rate of change in this situation. So even if you're given a graph, you can pull some points off, put it in a table to help organize your thinking. Okay, that's it for your study, buddy.